Hi all, welcome to this video. Building or configuring a new workstation or desktop for machine learning is a daunting task for beginners. So here I will share a step-by-step guide on how to set up the two most popular library for machine learning, that is TensorFlow and PyTorch, along with their dependencies like CUDA toolkit and cuDNN. And I'll also share suggestions if you are building a new desktop or workstation in the last section of the video. Even if you are not a beginner, it will help you to prepare environments for production deployment, or maybe you were using Kaggle or Google Colab for most of your work or research, and now you want something of your own. And since these platforms already come with most of the packages pre-installed along with their driver and CUDA environment prepared, you never got to do it on your own. Whatever may be the case, you have come to the right place. I will show you everything you need in details. I am expecting this video to be a bit long, hence I have provided chapter bookmarks if you directly need to jump to any specific section of the video. I will mainly do this on a Linux machine with Debian as the distro. However, it will be similar for any other distro for which NVIDIA have their drivers and CUDA toolkit available. And I will mention and share documents where these steps are different. Another assumption from my end is that you have an NVIDIA GPU. Steps will be significantly different if you have an AMD GPU or using only CPU. Now, without any further delay, let us begin. First step is to install an NVIDIA driver for your OS. Here I will install it for Debian. You have to look for your distribution specific documentation for more details. I'll share the documentation links in the video description for all of the popular distributions. Windows installation is also kind of similar, but for machine learning, Linux is more popular. Let me know in the comments if you want a video for Windows as well. Debian uses apt as package manager. Since NVIDIA drivers are not open source, they come under the non-free section of Debian repository, and you might have to enable contrib and non-free of this repository. Once done, we need to update the repository list using the sudo apt-get update command. So first we need to check if these are enabled. For me, this contrib and non-free section is already added. Once you add this section, you just need to do sudo apt-get update. Once done, you need to search for the driver using sudo apt-get search. Now look for this package. We need to install this one. For me, it is already installed, since otherwise I won't be able to record this video without a capture card. One issue you might find here is that in some documents it is mentioned to install NVIDIA Detect utility using sudo apt-get install NVIDIA Detect and then run sudo NVIDIA Detect to find the best suitable driver for your card. But this utility is a bit buggy. For example, if you see, I have the NVIDIA driver version this installed, and if you check the release page of the driver version, it is clearly mentioned that RTX 4090 is supported. But if I run sudo NVIDIA detect here, it gives me a warning that it is not able to find a suitable driver for my card. However, this utility works fine if your GPU is not of the latest generation. Most likely, they need to update this NVIDIA detect utility itself. After you are done with this installation, you should restart your system once. After you are done, uh, check your system using NVIDIA SMI command. It should report all of the details related to your GPU like GPU model, current power draw, power limit, current VRAM usage, etc. I will show you the installation and configuration for both TensorFlow and PyTorch. To use CUDA with these libraries, we also need to install CUDA Toolkit and cuDNN. We have three ways to install CUDA Toolkit and cuDNN. First, install TensorFlow or PyTorch and CUDA Toolkit and cuDNN using Conda as the package manager. This doesn't require you to create an NVIDIA developer's account. This is better if you only plan to use CUDA with TensorFlow or PyTorch, but not directly, since that will be a bit tricky. Second way is to install CUDA toolkit from your package manager after configuring the NVIDIA repo for your distro. But in this case, you have to log in and download cuDNN from NVIDIA since this package is restricted. We simply have to follow their distribution specific instruction. Third way is to get the installer directly from NVIDIA and install it on your distro. Similar to the second way, cuDNN will require you to create an NVIDIA developers account and log in. The second and third way is better if you plan to use CUDA directly with or without TensorFlow or PyTorch. For example, if you use C++. Here I will show you the first and second method. The third method is somewhat complex and screen recording is difficult as you need to log in to your cell before the graphical user interface starts up, and also need to unload NVIDIA drivers or any other generic display driver from the kernel. Also, you need to blacklist the generic display driver for your GPU. I'll share a link in the video description with the details if you are interested. Now let us begin. First, we will proceed with TensorFlow. But before that, we need to install Anaconda distribution for our Python environment, which we need to download from their official website. Go to the Get Additional Installer section and download the version appropriate for your environment. I already have it downloaded, so I'll just install it. Accept their license agreement. Specify the path you want to install it to. Now wait for it to get installed. I prefer not to init Conda while startup and rather add the directory in my environment path. Let us create a virtual environment first using this command. Now we need to switch to that environment. Once the environment is activated, we need to install the CUDA toolkit and cuDNN. This might take a while. Now we need to install cuDNN and TensorFlow. Now we need to add the CUDA environment for TensorFlow so that it automatically activates when we activate the TensorFlow environment. Once these are done, we need to link this environment to the Jupyter Notebook kernel. Now we will test our TensorFlow environment. First of all, check if the right kernel is being used. Also, if you want to see the execution time of each cells, then you need to install this library. As you can see, it is able to detect my graphics card, so it is working. Now we will train a sample neural network. Okay, looks like this is working fine. So now we will move to PyTorch. Again, we will create another environment for PyTorch. It is always better to separate TensorFlow and PyTorch in different virtual environments. If you plan to use them both, since they might have different CUDA toolkit or CUDA version as dependency, they might conflict with each other when used in the same environment. So if for any reason you need to install them in same environment, for example, you are using both TensorFlow and PyTorch in the same code, you need to find the common CUDA toolkit version which is supported by both. Now we need to activate the environment, and then we have to install PyTorch. So for PyTorch, it's actually simpler. So you have to choose your options accordingly. So since I'll be using Conda, I'm choosing Conda here and CUDA 11.8. So I'll just copy this command and run it here. It will automatically install PyTorch and all the related dependencies. Now sometimes you might face some issue with Conda. I don't know what is the issue actually. But if that happens, you can choose the pip version of the command and it will work. So I'll just cancel this. This might take a while depending on your internet speed. Seems like there is some issue with their website since I have 100 Mbps connection. So I should be getting at least 10 Mbps. Well, that was really painful. Now we have to uh, link the Jupyter notebook, same as TensorFlow. Now we need to test our installation was successful or not. So that we will start Jupyter notebook again. I'm getting some error that kernel does not exist. Uh, that is fine actually because we stopped it earlier. Now select the kernel. Okay, I needed to install it. Now there are several ways to make PyTorch use CUDA. Unlike TensorFlow, PyTorch by default doesn't use CUDA, so you have to specifically mention it. Also, another thing to note here that if you use CUDA with PyTorch, then while using another libraries like Matplotlib or NumPy, you have to explicitly transfer it to the CPU. Otherwise, it won't work because Matplotlib or NumPy does not support GPU. So again, this is a very simple neural network example. Or rather linear regression. Anyways, as you can see, our environment is working perfectly fine. Now we'll test with a bigger model. So for that we have to switch to TensorFlow kernel since I am using a TensorFlow model. As you can see here I am using some advanced options like limiting the memory size and then checking which devices are available, but these are not required for TensorFlow. Even this is a very small model compared to the computing capability of a 4090. See, it's not even using the full power. And the memory usage it's reporting, it's from the previous kernel that I executed. As you can see, I just ran it for 2 epochs, so the accuracy is not that good. Anyways, our installation was successful and we now have both TensorFlow and PyTorch working. So now we'll move to uh, directly using CUDA. So for that I have written a simple program both in GPU and CPU to show you the difference in speed. So first let's compile our CPU program. And then let's compile our GPU program. So for that you have to use NVCC and it needs to be in your path. But before that we have to install CUDA toolkit and QDNN at OS level. For that we have to go to this website. There are two options basically. One, you can download the dev package which is for Debian and install it to set the repository. Note one thing, it won't install CUDA. Okay, it will only install the repository. But I prefer the manual way. So uh, basically what you have to do, you have to first get this GPG key and you have to change this Debian 11 and the architecture according to your OS. So since I'm using Debian 11, it's Debian 11 here, and this is most likely you are also using 64 bit. So for 64 bit this will be the same. So first we have to get this file. And now we have to move it to the user directory, user share keyrings. And now we have to add the repository. Okay, looks like this is not available, and this is not required actually. Uh, it just prioritize that CUDA repository, but this is not required, so you can just go ahead now. Now another thing to note here is, uh, here they are suggesting to install this package CUDA, but if you do this, then it will automatically update when you run dist upgrade command. Okay, but that is not what we want, because PyTorch and TensorFlow both are dependent on some specific version of CUDA. So it's better to install the package directly by their version, so that it will only upgrade if there is a patch available, like minor version. For you, the download will be bigger most likely, because I had it already installed and I removed it just to test it, so that it didn't download the full set of libraries. Now to check if the installation was successfully done, we need to check if this directory is present. It should automatically create a soft link in user local directory named CUDA. So as you can see, this is present. If in any case, if you don't find that folder, then you have to point this folder and create a soft link. Can use the below command to create a soft link. So this will enable us to maintain CUDA version more effectively. Once this is done, we have to download QDNN from this link. Remember that we have to log in to download this package. So you need to create a developer's account if you don't have already. Once you are logged in, you will be able to download QDNN. Click on download QDNN. You have to agree to their license terms, and then choose the download option for CUDA 11.x version. Now we also have packages available for Debian, but I'll be installing the tar version, since that is a bit easier to maintain. So this is already downloaded. Now you can go to their installation guide and follow from there, but you have to follow the tar version installation rather than the Debian local installation. Now we just have to copy this extracted file to CUDA directory. Let's wait for the extraction to be completed. Now we want these libraries to um, configured in the LD config. So for that we have to go to this directory and create a file there. You just need to add this line, this file here. Now you have to do another thing, like you have to add this CUDA home variable and export the bin path. So you can edit your bash rc or js rc or any other cell you are using, and this will be your this will be inside your home directory, users home directory. So you just have to add these two line there, and then you have to run this command so that the libraries are recognized and available for nvcc. Now we can check if this is working. Now we can go ahead and compile our program using nvcc. Oh, now we're checking the time taken by cpu, and similarly we'll check time taken by gpu and then compare. As you can see, the gpu one is much more faster. Now we have successfully finished our installation. Feel free to skip this chapter if you already have a system and don't plan to upgrade it anytime soon. So first of all, if you are planning to build a machine learning desktop or workstation, then I would consider these things. Prefer NVIDIA GPU. As much as it pains me to say this, but there is no competition in this area unlike for gaming. Currently, there is no better alternative than CUDA for machine learning, and NVIDIA's software stack is phenomenal. Go with the GPU with the most amount of VRAM you can afford. For example, I would go with a RTX 3060 12 GB than a RTX 3070, even though 3070 is significantly faster than a 3060. But if you don't need the 12 GB, then go with the 3070. But remember that you will be limited to 8 GB of VRAM. And another note is that recent games are using more and more VRAM. Then Kaggle and Google Colab both give you GPU with 15 GB of available VRAM. So that is also another option if you are budget limited. But they both come with their limitations like session timeout, less hard drive space, low CPU power, etc. Now coming to RAM, you should at least go for 32 GB. Reason behind this is if you train a model in CPU, it will take ages. But still you can use CPU and RAM for inferencing a larger model, which you cannot fit in your GPU. Of course, it with slower speed, but at least you will be able to do it. Also, if you're building a new system, then check if your cabinet will support the GPU size. I recently upgraded my system from a tiny RTX 2060 to a Mammoth RTX 4090, and I had to get a new cabinet. Also, the motherboard needs to be sturdy and big enough if you are going for 4090 or plan to upgrade it to later. For my case, the 4090 bent the motherboard connector. Fortunately, it didn't damage it, but there is a visible bend in the motherboard connector beyond what I am comfortable with. As they say nowadays, earlier people used to feed a GPU to the motherboard, but now you feed a motherboard to the GPU. Power supply is also an important factor. A good PSU will probably last you 10 years or more, but if it cannot support the power demand, then you have to get a new one. So, depending on your budget, get the best and powerful PSU. Never compromise on a PSU, as if it goes down, it will take a lot of other things with it. This is it for the video. Please like, comment, and subscribe to see more contents like this. I am planning a full machine learning video series with detailed maths and from a very basic level. Since this is a very small channel, your likes, comments, and or subscription encourages me a lot. Thank you for watching. See you in the next video.